Lesson 3.4, find and use slopes of lines. This lesson is a review of Algebra 1, so I'm going to quickly go over this. The slope is the ratio of the vertical change rise to the horizontal change. The run between any 2 points on a line. Now the slope of the lines in the coordinate plane. The negative slope falls from left to right, as in line J. So from left to right. The positive slope rises from left to right, as in line K. The undefined slope is vertical, as in line N. And the zero slope of 0, is horizontal, as in line L. Example 1, find the slope of line A and line C. So I'm going to use the formula y2 minus y1 over x2 minus x1. Remember, m slope equals the change in y over the change in x. So for line A, I'm going to use 0.46 and 0.02. So it will be 6 minus 2 over 4 minus 0. So that's 4 over 4, which equals to 1. And for line C, the slope will be, so line C, I'm going to use 0, 6, and 4, 6. And while it's horizontal, the slope is automatically 0, but to show work, this is the work. Slopes of parallel lines. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So if these two lines are parallel, then their slopes are the same. And any two vertical lines are also parallel. So we're talking about two vertical lines in a coordinate plane. So if this were the x and y coordinate axis, then if this were line 1, line 2, and they're vertical, then they're always parallel. Okay, and slopes of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if we look at the picture to the right here, if the slope of this line is m1, and this line, which is perpendicular to the first one, is m2, then the products m1 times m2 is -1. Example 2, line N passes through the points 1, 6, and 8, 4. Line M passes through the points 0, 5, and 2, 12. Is N perpendicular to M? Explain your answer. So for line N, I'm going to find the slope. Line N, 4 minus 6, 8 minus 1, which is -2 over 7. And for line M, so I'm just going to do a little m here, which this little m is different from this big M, which this big M stands for slope. 12 minus 5 over 2 minus 0, which is 7 over 2. Now let's check. -2 over 7 times 7 over 2, and it's -1. So yes, perpendicular. Example 3, find the slope of each line. What lines are parallel? So can take line K1, we take -6 minus -1, -4 minus -3, and this will be -6 plus 1, -4 plus 3, negative 5, negative 1, which is just 5. And line K2, I'm going to use K2, 2, 2, and negative 1, 4. So I'm going to take negative 4 minus 2, and 1 minus 2, negative 6, be 6. And K3, I'm going to use 4, 2, and 3, negative 3. The slope will be negative 3 minus 2, 3 minus 4. Negative 5 over negative 1, which is 5. So, because the slope for K1 is 5 and K3 is also 5, so K1 is parallel to K3. Okay, example 4. Line H passes through the points 1, negative 2, and 5, 6. Graph the line perpendicular to line H, and that passes through the point 2, 5. Okay, for the first step, you have to first find the slope of M1 of H through 1, negative 2, and 5, 6. So that would be taking 6, subtracting that from negative 2, 5 minus 1, 8 over 4, and that would be 2. And the slope of the first line, so this is the slope of line H, is 2. How do you find the slope of the other line? You will take the negative reciprocal. Okay, so the negative reciprocal will be negative 1/2. So if we take 2 times negative 1/2, it will be equal to negative 1. Now, we're going to use rise over run to graph the line. Since this line has to go through the point 2, 5, which I plotted for you already, I'm going to shift down 1 unit because it's negative 1 in the numerator, and shift right 2 units. And this point would be 4, 4. And we can draw the line. Example 5. A trucker made 3 deliveries. The graph shows the truck's distance to the destination from the starting time to the arrival time for each delivery. Use slopes to make a statement about the deliveries. So here I can conclude that the rate at which the trucker drives is represented by the slope of the segments. So the segments A and C, the A and C, have the same slope. So deliveries A and C were driven at the same rate. And we will continue the lesson in class.